That's when I found Ayush and I learned about his course.
I personally seen you grow over time from where you started. I was checking your assignment to the level of answers which you have written in your examination, to the level of projects which I have personally seen, which you have built by your own. So I want to know answer of two questions first of all. What is t-test? And before that, I want you to tackle the question why do we need testing over here?
Right. So t-test is one kind of hypothesis testing. And what hypothesis testing does is it quantifies whether or not the result has occurred due to chance or some random event. From after training the model, obviously artifacts will be created. And then we have the front end and back end. As I said earlier, the back end is fast API and the front end is Streamlit. So the entire thing we have containerized it using Docker. For the visualization, I've used Plotly. So again, yeah,
Good.
outliers as well. I've used box plots. So as you can see, for
Very nice. Very
rotational
nice.
speed and torque, there are a few
Yeah,
outliers,
yeah,
right? And yeah, correlation matrices.
yeah.
And then I've done hypothesis testing as well. I've put it into a nice table.
Wow, that's so good. That's so good.
So yeah, monitoring reports, right? We'll have to monitor what kind of whether the data is changing or not. So data drift basically sees whether there is any statistical changes in the data from the trained data to the current data. Performance measures again, whatever I've trained, right? I've trained
Good.
multiple models, so we are just checking as which is the best performing model.
Hey Vishwas, welcome to the interview.
Thank you, Ayush, for inviting me. Glad to be here.
It's so amazing to have you over here and interview. And today, what I'll do is I'll have fruitful conversation with you and make sure that we test you on the data scientist profile.
Right, I'm excited.
So, what exactly I want to do is I want to start off with a very basic introduction of yourself, and after that, I'll ask you some of the questions around it so that we know that you're best fit to the company, as well as at the end, I've given you the take-home challenge prior, so we'll assess your take-home challenge which you have built by your own.
Right.
So
Yeah.
let's get
So,
started
hi
with your
everyone.
introduction.
My name is Vishwas Gowda, and I'm from Bangalore. I'm 20 years old. I'm currently pursuing my BTech in computer science. And for the past 3 years, I've been actively involved in the world of AI and ML. First, I started off as a content writer. I started writing content for my own purposes. I published them on LinkedIn and other platforms such as Medium, etc. And then I got quite a few traction there, and I got a few freelancing gigs. And then after that, I cracked an internship as well in a company called Entropic AI. So I did a 3 month paid internship there, and that was quite the experience for me. And from then on, I got back to freelancing again, and again I got a very good freelancing gig with a company called Sensorth AI. They are one of the leading AI startups in India, and again that was a big learning curve for me, and that was quite the experience as well. And then, of course, I thought this was the right time to get into actively building machine learning projects, and that's when I found Ayush, and learned about his course. So, and right from the beginning, I was zoned in, and I was actively learning and building AI ML projects with under the guidance of Ayush. And it's been quite the ride for the past 6 months. I've learned a lot, and I've come a long way from where I was 6 months ago, and I did well in my exams as well, and here I am now.
That's very amazing to hear from a guy who has actually gone through writing technical content and somewhere to actually building the projects or and he has passed through and has stopped in Antern examination which we has conducted a month ago, and it's quite amazing to see his journey as of now. So I have one question, Vishwas, maybe I would like to ask that can you tell me that what exactly the content which you used to write prior, and yeah, so just go with that.
So yeah, the content was more of a business uses content rather than technical content. So let's say with Entropic AI, right? I used to write about how AI is applied in market research. So it was more of business use case and case studies and opinion articles rather than technical content. So that's how I got very curious with the world of AI.
That's something amazing to hear as well, that you're already working in some sort of domain and you're trying to reconnect the domain, like you found something interesting and you wanted to get into AI and get into depth. And I've personally seen you that because I have a tendency to observe my students, whoever is in the batch, And I personally seen you grow over time from where you started. I was checking your assignments, so from where you started to the level of answers which you have written in your examination, the level of projects which I have personally seen, which you have built throughout by your own. First of all, congratulations for all of this.
Thanks a lot, Ayush.
Sure. So all of this is good. Like now, let's get to the actual point. Is I am going to interview you on some data science questions,
Right.
and of course, it will be not be easy. I'll ask questions which is actually asked in real interviews, and make sure that I assess each and every skills. I have never given you the questions which I've asked.
Right.
So if maybe the viewers are thinking that I've given him, that's totally wrong. Uh, I've made completely new set of questions, and it's not like that. He's an Antern student. I'm going to just show him the questions. I just going to ask this way, that the way I'm going to ask any interviewer out, any candidate out there. So let's get started with the interview.
Yeah, sure. Let's go.
Okay, Vishwas, my first question to you is assume that a researcher is analyzing the effects of two different teaching methods, for example, method A and method B, on a student's maths course. So basically, there's a teacher who is analyzing some sort of different teaching methods. There might be some peer learning or flipped learning. So he's like kind of method A and method B
Right.
on a student's maths course. He done a t-test out there. He done a t-test, and researcher obtains the p-value of 0.048. Okay, so basically he conducted a t-test where he got the p-value which is 0.048. Okay, now first of all, can you explain me that what is t-test and why there's a need of testing out there? Because basically, why there's a need of testing out there? So I want to know two answer of two questions. First of all, is first is what is t-test, and before that, I want you to tackle the question, why do we need testing over here?
Right. So t-test is one kind of hypothesis testing. And what hypothesis testing does is it quantifies whether or not the result has occurred due to chance or some random event. So in order to ensure that we can rely on the result, we need to conduct hypothesis testing, and t-test is one of the hypothesis kind of testing. Yeah.
Okay, so can you explain me some example of hypothesis testing? Like you say that it quantifies the results. So what exactly I didn't understood. Like, can you explain me in terms of examples?
Yeah, I can go with the same example that you've given. So
Okay,
yeah.
sure.
So in this case, the first step is to set a null and alternate hypothesis. So in this case, we could say that
Okay.
there is no statistical difference between, in terms of score, between the two teaching methods. That would be the null hypothesis.
Okay.
And the alternate hypothesis would be
Okay.
that there is a statistical difference between the scores in the two teaching methods. So once we've set the null and alternate hypothesis, then comes the testing. So as you said, we are going with t-test in this case. So we would calculate the t-test statistic score. That again is done through a table, which can be done through a calculator. And after that, we calculate the p-value for it. Now, what the p-value does is it tells us how likely this event or observation has occurred due to chance. So
Okay.
in case our p-value is less than a threshold value, let's say our threshold value is 0.05, we could reject the null hypothesis and accept the alternate hypothesis, which is that there is a statistical difference between the two teaching methods when it comes to scoring. So that's how we do it.
Okay.
Yeah.
That's good. Like, yeah, I'm convinced. So, I said the p-value will be 0.048, right? You have given the answer of the next question as well, which is what exactly this p-value does. But I have two questions right now. Is the researcher who was testing the methods, which is method number A or method number B, can he conclude that there is a significant difference in math scores between those two teaching methods, given the p-value is 0.048, and consider the significance level as 0.05?
Yes, he can, because 0.048 is obviously less than 0.005. So we could easily conclude that there is a statistical difference between the two teaching methods in terms of scoring.
Okay, can you tell me the null hypothesis and alternate hypothesis in this case?
Okay, the null
So what
hypothesis.
exactly we are doing with null and alternate? Are we rejecting null hypothesis? Like, explain me that reasoning.
Yeah, we are rejecting null hypothesis. Since 0.048 is obviously less than 0.05, we are basically saying that
Mm.
there is very less chance that this event has occurred due to random chance. So that's why we are rejecting the null
Good.
hypothesis.
Very nice. I expect this answer from you.
Yeah,
First of all, I have asked this question to so many people, and it's a very less people who are able to actually understand the core of it, because this is kind of a question which only needs the core understanding. I really appreciate that you are aware about that.
thank
First
you,
of
thank
all,
you.
a very good answer from you. Nice. Cool. So I have another question for you, which is another case study type of question, and the question is that a data analyst is working with a data set which containing the information on the daily number of visitors to a theme park. Okay, so he's actually working with a data set which has the daily number of visitors in a theme park out there over the past 12 months. So data is the basically number of visitors in the theme park over the past 12
Okay.
months. And the analyst notices a bimodal distribution in the data with two distinct peaks. Okay, so in the data he shows bimodal distribution. First
Right.
of all, can you tell me what is bimodal distribution?
So bimodal distribution basically means there are two different peaks in the distribution instead of one like we have in a normal
Hmm.
distribution. So that's what bimodal distribution
Mhm.
means.
Good. So now the theme park offers two types of tickets. First is a regular ticket, and second is a premium ticket,
Okay.
which offers additional benefits as well as you told. So there's two types of tickets. Now, can you tell me first of all, key what is the possible explanation? Whatever you think about that explanation, can you tell me what is the possible explanation for that bimodal distribution in the daily number of visitors in that theme park?
So the possible explanation for the bimodal distribution is that since, as you told, that there are two different type of tickets, one is a regular ticket and one is a premium ticket. So there might be two different sets of visitors who are buying, who opt for some who opt for regular and some who opt for premium tickets. So that's why we were seeing
Hmm.
two peaks in the distribution.
No, so how does it make sense? Like, I want to know that there are that on the days, like, what is the reason behind it? Okay, so you told that a ticket might be the same as that, right? The number of a ticket sold should be the same as the premium ticket, right?
Right. Yeah.
Okay, cool. Okay, so now, uh, on this basis, is there any other possible explanation which you can think of?
As I said that people might be buying regular tickets who are closer to the who are locals of that near that theme park, and they might have more free time and they're just looking to just visit the theme park. And there might be premium ticket users who have come from far along and who are looking to really spend and have a great time on the theme park. So that's the reason that there are two different peaks, and both tickets are selling at a good rate.
Okay, fair.
Yeah.
I agree with your explanation. But one thing which is going on in my mind is the presence of a bimodal. How does that affect, like, the if the bimodal distribution is present, how does this affect the interpretation of our descriptive statistics such as the mean, median, or standard deviation
Okay.
in this particular context? So how does that affect the interpretation of our mean,
Okay,
median?
I'm going to start off with mean. So the thing with
Okay, sure.
mean is that mean is always influenced by extreme values. And in this case, since there are
Yeah.
two peaks in the distribution, what would happen is that mean would not actually be a correct representative of the central tendency. It would fall somewhere in between the two peaks. So I would say that mean is not a good representative of the central tendency of the distribution. And then
Good.
I think you asked
Very
of
good.
median as well. So I think a median would be
Yeah.
a much better representative of central tendency. And that is because in median, what happens is we sort the values and then take the middlemost value. So when we are sorting the values, we would automatically get the highest peak. And I think that would be the best representation of central tendency compared to mean.
Very good. That's very amazing that you pointed out the assumptions of both the mean and median, and it's nice. Okay, so I have another question for you. Is my question? works on like a last question on this on this section, as I divided my questions into sections. So I have a last question on this. You have a 95% confidence interval for the average user time spent on a web page.
Okay.
Okay. And that is 300 to 340 seconds.
Right.
So can you first of all, instead of this particular number and all, can you explain me what is confidence interval
Okay.
and how can we interpret?
Yeah.
Just take a random example or literally anything.
So confidence interval, what it basically does is it gives us a particular range of values where the true mean of the population is likely to fall in with a certain level of confidence. So that's where confidence intervals
Okay.
comes in. So
Okay.
can you repeat the example you gave me, please?
Example was that there is a 95% confidence interval for the average user time spent on a web page, and that is
Right.
300 to 340 seconds.
Okay,
Yeah.
okay, yeah, got it. So as you said, with the 95% level of confidence, you're saying that the true mean of the average time spent on the website can be 300 to 340 seconds. So basically, that means that we can say with 95% confidence that the true mean of the average time spent on the website will be somewhere in between these two values.
Good.
Yeah.
I expect keywords, and I'm getting keywords from you, which is a nice one. Good. Cool. So I'm done with the first section of my questions. Now I'm going to go to the next couple of sections. And the
Okay.
next question is that can you define and explain me the concept of correlation, as well as I want you to differentiate between positive, negative, and zero correlation. And also I want you to provide real world example of correlation. Okay, go ahead.
Okay. So correlation is another statistical concept that basically describes the relationship between two variables. Now it describes both the strength and the direction of the relationship. So first you asked
Hmm.
about positive correlation, right? So in positive correlation,
Yeah.
what happens is that as the value of one variable increases, the value of the other variable increases as well. So basically they
Okay.
move in the same direction. And vice versa is also possible that as the value of one variable decreases, the value of the other variable decreases as well. So, and you asked for an example as well. So, a good example of this would be, let's say, the number of the scores of a student directly increases when the number of hours studied also increases. So, that would be a good example for
Good.
positive correlation.
Very nice. One thing which I just, it's very nice. The answers are correct. Just one thing which I would just like to address is whenever you're explaining something, try to explain with a support of an example. Don't
Right.
include example after that. For example, you told that a variable A increases when variable B increases. So maybe take one example prior. For example, say that we are working on a problem statement that we have that student score. We want to predict the student score based on number of hours he studied. So take that example first and
Okay.
explain how correlation comes into this place. Then it will
Okay.
be more specific to the whoever is going to whoever is like asking the question. It's like very clear, and it supports it as well. Explain the interviewer that you're explaining to a kid. That would be the best mentality which you
Okay.
can adopt.
Okay. Yeah. First,
Okay,
we'll start off
cool.
with the example and then
Yeah, go ahead.
I'll, yeah.
Yeah,
Okay.
yeah, that's good. Cool.
Okay.
So now I just want to go ahead and talk about something about A/B testing, and
Okay.
uh, maybe people usually ignore these questions, but I will touch these type of questions out there. So let's say that you're working. Listen my question carefully so that you understand each and everything. So just listen it. So Vishwas, let's say that you're working on an e-commerce store and a new marketing manager joins the company.
Right.
Okay. And redesigns the existing new user email journey. So basically, whenever something happens, a marketing manager is changing something, a user email journey to try and boost conversion rates. Okay. So basically, a new marketing manager comes in, changes something for the goal to change to increase the customer conversion rates. And a few weeks after launching the new email journey, the new conversion rate goes from 40% to 43%.
Okay. Hmm.
First of all, tell me it is good or not.
Yeah, since the conversion rate has increased, so that is obviously good news for the company.
Good. But before you celebrate the whole
Hmm.
scenario, the company CMO points out, the marketing, CMO points out a troubling fact.
Okay.
The fact says that few months prior to the new manager, whenever a few months back, before the new manager comes in, the conversion rate was already on
Okay.
45%
Hmm.
before slowly dropping down to 40%, right? So, how would you investigate if the redesigned email campaign actually led to that increase in the conversion rate? Because there might be some external factors, right? There
Right.
might be someone mentioning on a billboard or somewhere like that, right? So how can you tell that the change in your email campaign only is the reason behind increase in the customer conversion
Right.
rates? So I want to know the reasoning behind it.
Okay. So I'll break this down into a few steps for you. Okay, so the first step would be to gather the data. We have to collect all kinds of data that was before the new campaign and after the new campaign as well. How the metrics, such as different kind of marketing and sales metrics, and different the conversion rate changed. So all that kind of relevant data, maybe user demographic data as well. So all those kinds of data we can collect, and the next step would be to analyze the data and look for any patterns or trends that are quite apparent by visualizing it. So that would be the next step. And then, and as you said, there could be definitely external factors leading to the increase in conversion rate. So first, we have to ensure that that is not the case. So we must ensure that it's not because some kind of website redesign, or maybe the product itself was changed, or maybe because the user behavior itself changed. So we must ensure that that is not the case. And once we are sure with that, then we can finally come to A/B testing. So basically, what A/B testing allows us to do is we segment the users into two different groups, and the one group would be called the control group, and that group would be shown the old email campaign, and the second group would be called the treatment group, which would be shown the new email campaign. And after that, we analyze the conversion rate after they are shown the different email campaigns, and then we decide whether as to whether it's actually because of the email campaign or not, and then we can perform
Okay.
statistical tests as well on it. Yeah,
Okay, very nice. That's what your answer
yeah.
is. And one thing is, like you told initially, that we need to gather data and all, right? So if we are conducting A/B testing, then what's the need for gathering data from the past?
That is just making sure that there is no some external anomaly, and that there is actually,
External.
yes, we are just making sure that
Got it, got
everything's
it, got it.
in order, and yeah.
So how can you make sure the external factors are not there just based on data?
I'm sorry, I didn't get you.
How can you make sure that the external factors are not involved based on what the data which you have?
Let's say that there is a new website redesign, right? That could be one of the external factors. So, and let's say that the conversion rate also increases at the same time that the website redesign has taken place. So then there is quite conclusive evidence that this could be the very good reason why the conversion rate has increased, and we could conclude that there is external factor there. So if that kind of evidence is not there, then we can definitely say that the external factor is not the reason, and we can go forward with the A/B testing.
Okay, fair.
Yeah.
Good. Let's proceed to the next question. The question is: suppose we have built a regression model,
Okay.
okay, to predict the customer lifetime value.
Okay.
Okay, so you know predict what is the lifetime value of a
Okay.
customer, and it has a very high R squared value.
Okay.
R squared. So, however, when you deploy it in the real world, the model which you have built, the regression model,
Okay.
it does not perform
Hmm.
well.
Hmm.
So, what could be the possible like what is the reason behind it is not performing well despite of having high R square value?
Okay. It has a high R squared value, but it is not performing well on the real world data. Okay.
Yeah.
Yeah. So there are a few different possibilities as to why this is happening. So the first one I would like to explain is called overfitting. It's a phenomenon called overfitting. So basically what happens is the model learns the noise and the complex structures and the patterns unique to the training data set. And then when it learns the patterns of the training data set, obviously it won't perform well on the testing data set. So maybe that's the reason why overfitting is happening. And then again, there's a there could be a reason that there's a class imbalance if it's a classification model. So maybe in the training data set, the kind of patterns that are there in the data is not the same as in testing data. And that's why the prediction is not taking place. And the other one is obviously that the data pre-processing or data cleaning steps have not been done properly. There could be missing values or duplicate values, or there could be a lot of outliers. So that is one more reason as to why.
But one thing over here is I've told her it's a regression model. It's not a
Okay, okay,
classification
sorry.
model.
Yeah, got
Okay.
it.
It's a regression
Okay,
model to predict the customer lifetime value, and it has a very high R squared
okay,
value. Assume that on the testing set as well.
okay. Yeah,
But why it is not performing
yeah,
well?
that's what.
Assume that overfitting is not working. Then
Yeah, like I said, the pre-processing thing might have not been done properly. So the whether it could be handling missing values or removing outliers. If there are one too many, then obviously the data will not perform well on the training testing data set. And one more reason why that could happen is that the user behavior itself has changed from the training model. And that's the reason that maybe it's not really representing the real world data. So that is one
okay, good.
issue as well.
So how can we tackle this? How can we tackle this?
When it comes to, yeah, again, I think since the problem is with the data itself, then we'll have to
Ah,
revisit our data collecting and data aggregating steps.
very
Yeah.
nice. Good. Can you explain me like what are the advantages and disadvantages, like comparison between regression, linear regression, and decision trees for regression tasks?
Okay, linear regression I think is a more easy to interpret model since basically we have coefficients for each feature. We can just rank according to their absolute value and find out what kind of features has a bigger impact on the target variable. So definitely it is more interpretable in terms of that. And another advantage I think linear regression has is that if the linearity assumption is satisfied, which means that the relationship between two variables is similar to a linear relationship, then I think definitely going with linear regression is the best option. And again, linear regression works well on simple models, so I think that's the best that's the most suitable for linear regression. And you asked about decision trees as well, right? So I think decision tree works best when the data is complex and non-linear. So that is something which the linear regression does not handle well, and decision trees performs much better. And also one more big advantage that decision trees have is that they do well with categorical data, whereas linear regression specifically requires numerical data. Decision trees, whereas they can handle categorical data and any kind of non-numeric data.
Can you also tell me the trade-offs between precision and recall?
Okay, so I'll just give a few points about precision and recall before I get into trade-off. Yeah. So I
Yeah.
think both are basically performance measures used in classification models, and they tell us about the correctly predicted values. They measure the correctly predicted values. So what precision does is it's a proportion of the correctly predicted positive values with the amount of the total positively predicted values. So the
Okay.
formula for precision would be like true positives by true positives plus false positives. So that would be the formula for
Okay.
precision. And
Good.
recall gives is the proportion of all the correctly predicted positive values by the actually correct positive values. So precision
Okay.
recall the formula for recall would be true positives by true positives plus false negatives. So as you talked about the trade-off between the two, So there is definitely always going to be a trade-off. Whereas if the precision increases, the recall increases, and if the recall increases, the precision decreases. So there is obviously a trade-off, and there is a need to balance them according to the business use case. So there might be
Right.
scenarios where we would prefer the precision score to be higher compared to the recall, and vice versa.
Very nice. So we'll come to a very basic now, so that we you have a very strong fundamentals. I want you to do one thing. What I want is an e-commerce company. Okay, so an e-commerce company wants to optimize their advertising budget allocation across different marketing channels, which is TV, radio, and social
Okay,
media,
okay,
right? And the company has some collected some historical data, right? And you want to model a regression relationship on it,
okay.
right? To estimate what will be the sales if we put our money on one of the source. So can you explain me that the whole process, like the whole process of how you're going to apply regression algorithm on top of it?
Okay. The first step to build a linear regression model, or any model for that matter, would be data pre-processing. So in data pre-processing, basically we collect the data, and it could be different, like as you said, advertising expenditures across different marketing channels. So we'll have to collect all that data, and then we'll have to perform data cleaning, where we will handle all the missing values, any kind of data inconsistencies, or changing the data types, or removing any outliers or duplicates. And then we could perform data transformation techniques, such as standardization and normalization, so that all the features are on the same scale, which is basically feature scaling. So that would be the first step, that is data pre-processing. After that, we could do certain feature selection. So feature selection as well, we can perform certain feature engineering, where we create new features based on the existing features. So maybe we want to create new metrics such as average order value, or click-through rate, or something which is related to the advertising channels or marketing metrics. We could create those features as well, if that is relevant to the business. And then in feature selection, again, we could perform a correlation analysis, where we find the correlation, we construct a correlation matrix, so that with every combination of feature, we find the correlation and identify which features could potentially be quite important to the target variable. And that would be feature selection. And then I think we'll come to model training. So before model training, we'll have to obviously split the data into training and testing data. We could do after that. After splitting the data, we'll have to select the model. And since you've already said this is a multiple linear regression, so we could go with that as well. We could go directly with that. Then next step is obviously training the model. So once we train the model, we might get the performance measures such as R2 score, or RMSE, or MSE, any of those. And according to those measures, we'll have to optimize them. So that step is called hyperparameter tuning. So we could use methods such as grid search or random search for optimizing the model further. And then comes model evaluation. Model evaluation, again, we'll have to see on how the model is performing according to different metrics, as I said before, according to root mean square error, or R2 score, or RMSE. And I think you asked about but how we will choose which advertising channel is most important, right?
Yeah.
Okay, yeah. So for that, we can follow a step called feature importance. So basically, how feature importance works is, in the linear regression is, we'll basically rank the feature according to their absolute coefficient value. So if the coefficient value of that feature is important, so we can say that that market advertising channel is definitely more has a bigger impact on sales and revenue. So that's how we can
Mhm.
decide which
Okay.
advertising channel is important.
You want to assess the significance of a particular variable input feature. How you going to assess the significance of a particular input feature, independent feature?
Significance of a particular independent feature.
Yeah.
Yeah, like I said, we can perform feature importance, and then we can rank it accordingly.
There's something a hypothesis testing So try to relate hypothesis testing for feature for taking out the significance of particular variable.
Significance of a particular. Yeah, we can perform a t-test and compare two different groups. There's one sample t-test and two sample t-tests as well. So we could do either of them depending on our use case, and then we can confirm through the t-test that this is not occurred due to some random chance, and this is, yeah.
Okay, can you tell me some of the assumptions of linear regression?
Yeah, linear regression has a linearity assumption, which means that there should be the relationship between the predictor variable and the target variable should be similar to a linear relationship. So that is one, and we should also, and one more is collinearity. Collinearity basically means that there should be no there should be no correlation between, there should be very low correlation between two predictor variables. So if there are two predictor variables that are highly correlated, that would affect the performance of the model. That is one, and the other one is ensuring that the errors in the values in the prediction are random, and they are not in a that they do not have a pattern. So that is one more linear assumption we have to satisfy in linear regression.
Good. You also told how to, talk about it. Very, pretty nice explanation about the assumptions of regression. Now, I would like to just go throw some light on unsupervised learning.
Okay.
So can you just explain me a bit about unsupervised learning along with the examples? And I want to explain about k-means clustering algorithm along with how do we select clusters in that algorithm. So just go ahead.
Okay, so unsupervised learning, where it differs from supervised learning, is that it does not have a target variable. So since we do not have a target variable, we are basically segmenting the data points into different segments according to the data. So there is no particular classification or any kind of target variable in unsupervised learning. And since you asked about k-means clustering, so basically what happens is that we calculate basically an inertia, that is the cost function we use in k-means clustering, and we select a random mean value for each. First of all we set the number of clusters, right? So it could be 4 or 5 depending on our use case, and once you select an initial number of clusters, the k-means clustering algorithm will select a few mean data points for the cluster, random data points. And from each mean cluster center, we calculate the distance to each nearing data point. And as we go on iterating through each step, what will happen is that the cluster center will move towards its actual cluster center, and there will be quite a difference between each cluster. So that's how each cluster is segmented into its own, each data point is segmented into its own cluster.
Good. Cool. So how do we select the number of clusters in that?
So initially we can give a number of clusters, but there are other methods as well called K-elbow method or silhouette score, which we can use
Okay.
for,
I just wanted to know
yeah,
the
yeah.
names. Good. That's very nice, and I really like the way you have the diversity of the knowledge.
Thank you. Yeah,
However, there's some points which I'll address by the end of this interview as a feedback for
sure.
you. But the level of the answers from a beginner, right? I think you're also going to sit in interviews as well. So the level of the answers expected, like it's quite amazing,
Thank you.
and the depth of knowledge which you have, the way you go deep down and explain me things up. I have seen very less people telling this much confidently to anyone, and first of all, appreciate you for that. Like, even there's like I can point out thousands of positive things like in this particular interview, not because like you're my student or you have came to this particular channel, but I want to address that I've seen so many interviews, right? I've also conducted so many of interviews, and the level of answers taken by you is quite amazing. So first of all, appreciate you
Thank you,
for that.
Ayush. I think you've also helped a lot with this, so credit goes to you as well.
Uh,
Yeah.
Sure. So now, what I want is now we are done with some, the questions which goes in depth. Now I really want to see your technical skills.
Okay.
So yeah, let's get started with viewing your project which you have built by your
So
own.
I'll start sharing my screen.
Yes, share the screen. So Vishwas is going to show me his projects which he built out there as a take-home challenge. So let's get started by seeing the Vishwas project. So Vishwas, can you demo about your project and what exactly you built? If I have some questions, I'll ask you along with that. So let's get started.
Sure. So my project is called Predictive Maintenance, and it's a full-fledged MLOps project. So you can view it on the web. There's a web app as well, which anyone can access from the internet. So let me tell you a bit more about what exactly this project is. So basically, we have a data set about how the different machines are at different times, and we have recorded their tool wear and power and process temperature and the air temperature during that time and various other features. And based on that, we are predicting whether the machine will fail or not. And if and when the machine fails, what kind of machine failure is it? Is it a hardware failure? Is it a power failure? Is it an overwear failure? So different kind of failures as are. So basically, since we are predicting two things, we'll have to build two different models as well, right? So that's what we are doing here. And then, of course, the success metrics and all I've listed down here: precision, recall, and F1 score, and different kind of metrics we are optimizing with hyperparameter tuning. And then the functional and non-functional requirements have been listed here as well. Users can provide the process parameters and receive a prediction. So prediction can be done through the web app I've built. And then I've also listed the different performance metrics for different kinds of model. It could be logistic regression or SVC, or it could be decision tree, or any ensemble method. So that I've listed as well. And then certain visualization techniques have also applied and listed it onto the web app. And then yeah, so that's all the features that the user can do. And then constraints, there are certain tools and constraints that I've used. The application I've been using for the backend is Fast API. So Fast API is extremely reliable and fast, and it can link the prediction value and onto the front end very quickly. So that's why I've used Fast API. And then comes Streamlit. Streamlit is an up and coming front end web application specifically for data science and ML and ML ops. So Streamlit as well is something I really like and enjoy building web apps through Streamlit. And then I've used Docker. So Docker is very convenient for deploying, since it creates its own container. It creates a virtual machine where the web app can be loaded onto and can be deployed easily onto any kind of cloud hosting platform. And the cloud hosting platform I've used here is DigitalOcean. I think DigitalOcean is very convenient and very reliable in terms of costs as well. So that's why I've used DigitalOcean. And then, yeah, the different steps I've followed. It could be data pre-processing, feature engineering, model selection, hyperparameter tuning. I've gone through all the steps, and the results have been pretty amazing as well. And yeah, this is a basic pipeline as to how the MLOps project works, and this is the MLOps pipeline. So basically, we have the data here, and then the pre-processing, model training, and model evaluation. All the steps takes place, and then from after training the model, obviously artifacts will be created where we'll store the model as a pickle file, and we'll store other transformations also as pickle files. And then we have the front end and back end. As I said earlier, the back end is Fast API and the front end is Streamlit. So the entire thing we have containerized it using Docker, and that Docker image will be deployed onto a DigitalOcean droplet, and that DigitalOcean droplet, through that we'll be running the web app, and the user can obviously give the input to the web app and obtain the predictions. So that is the basic workflow of my project.
What does that predictions goes from there to again data? Why does that happen? And I'm really interested in that
Yeah, so that is
dialogue.
basically the MLOps pipeline, right? So once we have obtained the data
Okay.
from the user, we will feed that data back to our original database or the data format, whichever we have stored in, so that we can keep updating our model, which will represent the current data rather than becoming stagnant or representing old data. That's why we'll have to feed that
Okay.
predictions back
Fair
into
enough.
the data. Yeah,
Okay, sure. Go ahead.
yeah. So I'll yeah, those are the basic workflow.
Good.
Yeah.
So I have some questions. First of all, I have some questions. Maybe I should get it clear. So have you worried about monitoring? Like what about monitoring? Because you have to make
Yes.
sure that you're monitoring the results.
Yes, as I said, that we'll be feeding the predictions as well. So we have to ensure that the model is working fine. We have to ensure that there is no model drift, and we have to ensure that the data is not, whether the data is changing or not. So we'll have to monitor the data drift as well. And to address that, there is a tool called
Good.
Evidently AI, which I think is very convenient.
Okay.
Basically, I can gain HTML reports and compare the model, the data, the models on which it was first originally trained, and compare the new model as well. So we can compare and gain a lot of insights from that as to how the data is changing and how the model is changing.
Very nice. Can you show me the all the things?
Yes, I'll show you my web app right now. So yeah, let me go to the main page. Yeah,
Wow.
so basically, again, I've just given an overview of how the model works and everything for the user to go through. This is just basic documentation,
Yeah.
right? And then, yeah,
Understandable.
and then, like I said, we can do certain prediction as well. So I've inputted there. These are
Okay,
some
got it.
just default values which you can of course change. You can make anything.
Okay.
These are all the input values:
Understandable.
RPM, torque, tool wear, and all different kinds of parameters that we're using.
Understandable.
Yes, and then we
Hmm.
can click
Hmm.
on
Yeah, predict.
yeah. So if I press predict, then it will predict whether it's machine failure and or not, and then what kind
Wow.
of failure it is
That's
as
so
well,
nice.
right?
Okay, yeah. That's so important as well in terms of business
You're right,
aspects.
right.
Good.
So it's not important that we just classify whether it's machine failure or not. It's also important
Uh,
that we understand what
what's
kind of failure is happening and what exactly is
right,
ailing the
right
business as well.
failure?
Right.
Yeah, true.
Okay.
You have also listed over the
Yeah.
EDA monitoring reports. I'm interested in that.
Yeah.
Show me the EDA.
So EDA, right? So EDA basically whatever we do in a Jupyter notebook, right? I've basically put it onto my front
Ah,
end Streamlit app. So right,
nice.
so I've just framed basic questions that is very relevant to the business and the company, and then just given some visualizations and what kind of inferences I've gained from that visualizations.
Visualization.
Right.
Good. Can you just scroll through it?
Yeah,
Like, yeah.
different type of questions, like what is the distribution of product ID, variable,
Mm,
or how many instances of low, medium, high. So I've listed all that and also
mhm.
gained some important inferences, and I've listed what kind of percentages are there as well. So yeah, for the visualization, I've used Plotly. So that is one thing. I think it looks very well on Streamlit web apps. So again, yeah,
Good.
outliers as well. I've used box plots to check whether there are any outliers. So as you can see, for
Very nice. Very
rotational
nice. Yeah.
speed and torque, there are a few
Yeah,
outliers,
yeah.
right? And yeah, correlation matrices,
Yeah.
and then I've done hypothesis testing as well. I've put it into a nice table.
Wow. That's so
Yeah,
good. That's so good.
and then yeah, it's a violin plot as well. So I've done those as well. Yeah, so that is the EDA. That
Uh,
is the basic EDA,
nice. Uh,
and then
I would like to point out a very nice thing about this particular thing. Is to my viewers as well. What Vishwas has added is not being seen by any of the beginners, 99% of the beginners out there. I'm really proud of it because of following reasons. Is not only thing is that there is one thing which is just added the visualization and is good to go. He built a good storyline out of it, like inferring things out there, right? He also showed the even the non-tech folks can understand it. Along with he has done hypothesis testing and says that okay, we reject and write the inference based on it. I'm truly amazed by the simple EDA which he has done and so amazing questions which he asked. And about that, that totally amazed me out there. Amazing, Vishwas. Go
thank
ahead
you, thank
with
you. Yeah.
monitoring.
So yeah, monitoring reports, right? As I mentioned earlier, that we'll have to monitor what kind of what whether the data is changing or not. So data drift basically sees
Uh,
whether there is any statistical changes in the data from the trained data to the current data. So as you can see, this is the current distribution of the data, and this is the reference distribution. As you can see, there is not much data drifting, so there is no data drift detected as of now.
we are good to go.
Yeah.
Hmm.
And then yeah, different models for the model one as well. I've created a report.
Mm, good.
Yeah, it takes a bit of time to load.
No problem.
Yeah, as you can see, it first of all like just specifies what kind of scores we are getting in terms of accuracy, recall, precision, etc., and what kind of distribution we have, right? What kind of
Yeah,
distribution we have of the class data set, and confusion matrix, and all the standard stuff that we will require to address the data set.
got it, got it.
Yeah.
Can you show me the performance
Yeah,
measures?
performance measures again, whatever I've trained, right? I've trained
Good.
multiple models, so we are just checking as which is the best performing model. So as you can see, I've
Which is
listed
the
logistic
best?
regression, SVC, decision tree, and random forest. Those are the four models that I'm using. And as you can see, that the best model I identify is random forest. As you can see, accuracy, precision, recall, everything is above 99%. So for both the models. So I think random forest has worked quite well for this.
Okay, cool.
Yeah, those are
So
the
I really liked the project. I'm really amazed that you don't only focused on one specific aspect. You taken care from business stakeholder aspect to the end, which is monitoring deployment. You come continuously monitor the results and the
yes,
continuous CI/CD pipelines, and it's quite amazing that it's something to be implemented in every other project. Like when you work, like exactly when I told you that these things to be implemented out there and you succeeded on that. That's pretty amazing, which I see, and that's what we expect Anternians to go with.
yeah,
And yeah, so that's pretty much it for the interview.
okay.
And yeah,
Thank you, Ayush.
so it was nice talking to you, Vishwas.
Yeah,
And personally, I haven't seen like very less students who's actually have a diverse set of knowledge, the fundamentals knowledge which we focus on. And I'm proud that Anton was able to help you in this journey and along with the from where you were, I personally seen you as I said to a long way, and it's quite amazing in some months
yeah,
only. And I really hope that you continue to do this. As I've given you some of the feedbacks, please focus on that as well.
yeah.
And and along with that, your project seems amazing. I hope that you're getting into some international companies in coming
Thank you.
days.
That's what I hope as well.
And yes, and I really hope that you grab some freaking per month package,
Thank you.
which means international gifts per month package, which is quite big, and that's what we and also we are helping our students as well, like you, who actually have the right talent and getting to a success and achieving it in a right way. We really hope that we help you out in a way that you required. And yeah, that's it from my side. If you have any words from your side, please feel to say.
Yeah, that's all. I would like to say thank you for all the support you've given me for the past 6 months. I've learned a lot. Like I said, it's been quite a journey. It's been a roller coaster journey, a lot of ups and downs as well. I've learned a lot, and you've taught me a lot other than machine learning as well. You know how to be disciplined and how
Yeah.
to have the right kind of mindset to have a lot of growth in career. So thank you for that.
Definitely, we focus on holistic developments, of course. You're most welcome. And now, then let's wrap up this interview and hope to see you in some international companies in coming
Yeah,
days.
thank you.